Warm welcome to the module on Charles' law. In this module, we shall think about the second relationship between the measurable properties, that is between volume and temperature. I will show a video. You have to observe it and find out what is happening. You can see that as the temperature increases, volume of the gas is also increasing. What you can say about this relationship? Yes, the relationship between volume and temperature is directly proportional. And you can see that the pressure and amount of substance are found to be constant. So we can state the relationship between volume and temperature of gases as in Boyle's law. This is like that if the pressure remains constant, the volume of a fixed mass of a gas is directly proportional to absolute temperature. This law was proposed by Charles and the law is known as Charles' law. What is the proportionality between volume and temperature? You found that volume is increasing with the temperature. So the proportionality is direct proportionality. That means volume is directly proportional to temperature or absolute temperature. So how can we represent it if V is the volume and capital T is the temperature? We can represent it mathematically as V proportional to T, where V is the volume and temperature is T in Kelvin scale. This temperature is denoted by capital T. Here pressure and amount of substances are constant. So the above mathematical relationship V proportional to T can be replaced as V divided by T equal to a constant. That means we can change the proportionality by a constant. So our equation becomes V by T equal to constant. Now let us consider a case of gas expands from volume V1 to V2 with the increasing temperature from T1 to T2. That means V1 is the volume at temperature T1 and V2 is the volume at temperature T2. Okay, so we can write the equation for Charles' law. Already we found that V by T is equal to a constant. So our modified equation is V1 by T1 is equal to V2 by T2. This equation is applicable for two different states. Charles and Gay-Lussac found that for each degree rise in temperature, the volume of a gas increases by 1 by 273.15 of the original volume of the gas at 0 degree Celsius. We can represent it mathematically. If the volume of the gas at 0 degree Celsius and at T degree Celsius as V0 and Vt respectively, then we can express the above observation by the following relation. Volume at T degree Celsius Vt is equal to V0 plus T by 273.15 into V0. Vt equal to V0 into 1 plus T by 273.15. So Vt is equal to V0 into 273.15 plus T by 273.15. Now we can represent it as 273.15 as T0 and 273.15 plus T as capital T. So the equation becomes Vt is equal to V0 into T by T0. On rearranging, we will get Vt by T is equal to V0 by T0. We can now define a new scale of temperature such that T degrees Celsius on the new scale is given by T is equal to 273.15 plus T and 0 degrees Celsius will be given by T0 equal to 273.15. This new temperature scale is called the Kelvin temperature scale or absolute temperature scale. Now let us draw a graph showing volume versus temperature. We already found that volume and temperature are directly proportional. So the graph will like this. Here the graph is plotted at constant pressure. So what you can call this graph? Yes, this is isobar. Iso means same and bar is the unit of pressure. So this graph is called an isobar. Charles found that for all gases at any given pressure, the graph of volume versus temperature is a straight line, and on extending to zero volume, each line intercepts the temperature axis at minus 273.15 irrespective of the pressure cases. Slopes of the lines obtained at different pressure are different, but at zero volume all the line meets the temperature axis at minus 273.15 degree Celsius. So what will be the volume of the gas at minus 273.0 degree Celsius? Yes, it is 0. Okay, so we found that volume of the gas becomes 0 at minus 273.15 degrees Celsius. Volume becomes 0 means that gas will not exist. In fact, all the gas get liquefied before this temperature is reached. The lowest hypothetical or imaginary temperature at which gases are supposed to occupy zero volume is called absolute zero. Now we shall solve one problem. You please note it down. On a ship sailing in the Pacific Ocean where the temperature is 23.4 degrees Celsius, a balloon is filled with 2 liters of air. What will be the volume of the balloon when the ship reaches the Indian Ocean where the temperature is 26.1 degree Celsius? In this problem, you can see that two temperatures, that is 23.4 degrees Celsius and 26.1 degree Celsius. And one volume is given, that is 2 liter. It is corresponds to the temperature 23.4 degree Celsius. So we have to find out the volume at temperature 26.1 degree Celsius. So which equation can be used? Yes, V1 by T1 is equal to V2 by T2. In this equation, we have to use the temperature in absolute scale. So we have to convert the temperature in degrees Celsius to Kelvin scale. The first temperature 23.4 degrees Celsius can be converted into Kelvin scale by adding 273. So T1 becomes 23.4 plus 273 and T2 becomes 26.1 plus 273. So we have the values for T1 as 296.4 and value of T2 as 299.1, and volume is given in the problem as V1 2 liter. So we can substitute these values in the equation. V1 by T1 is equal to V2 by T2. V2 is 299.1 Kelvin and V1 is 2 liter, and we have to find out the value of V2. The answer becomes 2.018 liter. Hope you all understood about the Charles law. Thank you, dear students. We all meet in the next class.